Testing. Testing. Oh, didn't see you there. Well, hey, while I have you here, let's talk about ellipses. In more particular, let's talk about what we call the foci of an ellipse, which is the plural form of focus or focuses, but I'm going to use the word foci. Now, let's take, for example, you're given this equation, general equation of an ellipse, x squared over a squared plus y squared over b squared equals 1, and I know that a is greater than b. Well, a couple of things I know about this ellipse. I know that the center is at the origin, 0, 0, and I also know that it's going to be a horizontal ellipse because a is greater than b and a is located underneath x. So I know this distance here. Oh, that kind of looks like a bat. That distance is going to be a. Let's see if I can make that a little bit better. That's a better bat. Oh, too soon. That's a. And then I also know that my vertical distance is going to be b. Okay, so those are a couple of things I know. Now, the most fascinating thing about an ellipse we haven't even talked about yet, and that is that there are 2 points that lie along the major axis and are symmetrical with the center. That means they're the same distance away from the center. Okay, and these 2 points I'm just going to call F1 and F2. And the most fascinating thing about an ellipse, and really the definition of an ellipse, is that if I find the distance between each of these points, we're going to call these focuses or foci. So if I find the distance between foci 1 and the point on the ellipse, and foci 2 and the point on the ellipse, and let's say I find, or I'm going to say that's D2 and that's D1. Okay, so if you construct those segments, okay, the sum of the distance, so if I add up D1 and D2, and this is true for any point on the ellipse, when I add up those 2 distances from F1 to a point and F2 and the point, it's always going to be equal to twice the major axis, or 2a, every single time. Okay? And that's really like the definition of an ellipse, is that an ellipse is the set of all points where the distance, or the sum of the distance between 2 other points, we call the foci, is the same or equal to twice the major radius. So let me show you what I mean here. So in this interactive, I can move this point around the ellipse, and if you notice, my major axis is 8. That means the sum of these distances here, of these 2 segments, PF1 and PF2, if I add those together, I should get 16. Well, if I move P around anywhere around the ellipse, notice how my distances for each individual segment is changing, but my sum is still 16. That is, again, the most interesting property of an ellipse, is that this sum never changes. Okay, now I also know a couple other things about it. I know that the distance from the center to each of the foci is the same, and that distance we call c. And I have a property that I can use, which is c squared equals a squared minus b squared, almost like the Pythagorean theorem, except it's minus instead of plus. Okay, and that's going to become very important to us down the road here. So let's take, for example, I have this ellipse, and I want to plot the foci of the following ellipse. So a couple of things I need to know in order to plot the foci. I need to know my A value, or my major radius. I need to know my B value, or my minor radius. I also need to use those two, and then use this formula, a squared, or c squared equals a squared minus b squared. See, I almost caught myself doing the Pythagorean theorem. No, no, no. All right, so A is the major radius. I can find the major radius. I know this is a vertical ellipse, which means my vertical radius looks like that's 3. That's 1, 2, 3, 4, 5. That's 5. And so A is 5. And B is going to be my horizontal distance, which is 1, 2, 3. Okay. So now I can just plug it into this formula and say, okay, well, c squared is going to be equal to 5 squared minus 3 squared. And then I could solve it from there and get 25 minus 9. And that is actually good because that's c squared equals 16, which makes c equal to a nice 4. Okay? So what that really means is that to get or plot each of my foci, again, they lie along the major axis, or the major axis. And what I do is I go to find each of these foci from the center. I go up 4 units. So 1, 2, 3, 4. That means F1 is going to be right there at that coordinate. F2 is the same thing. I just go down 4 units. So 1, 2, 3, 4. And that's going to be F2. Okay, and then I can go ahead and label those coordinates. So F1, that coordinate is actually going to be -5. And then I went up to 7. F2 is going to be -5. And then I went down to -1. So those are my 2 foci in this case. So now what if you're given the equation and asked to label or find the coordinates? Well, I'm going to show you right here. So given the equation below, what are the foci for this ellipse? Again, I need to know A and I need to know B, and then I can use that formula there. But first, let's figure out what I do know about this ellipse. Well, I know that first off, my center is 0, 2. I know that it's going to be a horizontal ellipse. How do I know that? Well, the bigger denominator, the bigger number is underneath x. So I know it's horizontal. If it was underneath y, that means it would be a vertical ellipse. So I know it's going to be wider rather than taller. Okay. I also know a squared is 15, and I know b squared is 9. Okay. I really don't even need to find a and b because my formula is c squared equals a squared minus b squared. Okay. So I can use that and say, all right, that's 15 minus 9. That makes 6. So c squared is 6, which means c is technically equal to plus or minus the square root of 6. All right. Now, if you think about an ellipse and a horizontal ellipse, this is my center, and let's say these are both of my foci, F1, F2. So C is the distance from the center to each of the foci, and that's the same distance. Okay. Now, if you think about it, it's a horizontal ellipse, so I don't have to move anywhere vertically. Okay. So to find the coordinates of F1 and F2. Well, F1, in this case, I went from the center and I added an x value to get to F1. So that means I'm going to take my x value of the center, which is 0, and add square root of 6. And my y coordinate, I'm not changing, so it's just going to be equal to the y coordinate of the center, which is 2. So it's square root of 6, 2. F2 is the same thing, except it's going to be 0. In this case, I went back. I went negative in the x direction, so that's 0 minus square root of 6, comma 2, which is the same thing as negative square root of 6, 2. So those are my two coordinates in this case. So let's look at another example. Same directions. I want to find the foci. So let's identify the center. Well, the center is -7, -5. Let's figure out next if this is a vertical or horizontal ellipse. Well, I know it's going to be vertical. How do I know that? Well, the bigger number, which is a bigger denominator, which is 37, that's underneath y. So I know it's going to be vertical. Okay? Which means I know it's going to be this skinny dog right there. So I know it's going to be vertical. Okay? I also know that a squared is 37, and I know b squared, a squared, and b squared is going to be 11. Okay, so then I can find a squared, or c squared, by using this formula. C squared equals a squared minus b squared. And saying, okay, a squared is 37, b squared is 11. Subtract those two big hosses, you get 26. So c, or the distance between the center and each of the foci, is going to be plus or minus the square root of 26. Think about it. Here's my center. And then each of my foci, those 2 points right there. So if you think about it, let's say this is F1, this is F2. I didn't move anywhere horizontally. So the only coordinate that's going to change is my y coordinate. My x coordinate is going to be the same as the x coordinate of my center. So F1, my x coordinate doesn't change. It's still going to be -7. The y coordinate is just going to be -5. And I went up, so it's going to be plus the square root of 26. Let's write that better. -5 plus the square root of 26. And then F2, same type of deal, -7, but I went down, so it's -5 minus the square root of 26. And there's that. Okay, and so now what I want you to do is complete the problems listed on the foci practice sheet. If you have any questions, let me know. Man, do I love saying foci. Foci, foci. All right, have a blessed day. Peace.